Understand the concept of mass spectrometry. A mass spectrum is an analytical tool that measures the mass-to-charge (m/z) ratio of gaseous ions. For singly charged ions, this directly displays the exact atomic mass in AMU and the relative percent abundance of each individual isotope present in a sample of an element. Analyze the data from the graph. X-axis, atomic mass. The peaks are located at 90, 91, 92, 94, and 96 AMU. Y-axis, percent abundance. The heights of the peaks show that the isotope at 90 AMU is the most abundant, approximate 51%, followed by 91 AMU, approximate 11%, 92 AMU, approximate 17%, 94 AMU, approximate 17%, and 96 AMU, approximate 3%. Estimate the weighted average atomic mass. The average atomic mass of an element is the weighted average of its naturally occurring isotopes. Average mass equals sum isotopic mass times fractional abundance. Average mass approximately 90 times 0.51 plus 91 times 0.11 plus 92 times 0.17 plus 94 times 0.17 plus 96 times 0.03. Average mass approximately 45.9 plus 10.0 plus 15.6 plus 16.0 plus 2.9 is equal to 90.4 AMU even without performing exact arithmetic. A student can quickly deduce that because the dominant peak is at 90 AMU and all other isotope peaks are heavier, the weighted average must lie slightly above 90 AMU, specifically in the 91 to 92 AMU range. Compare the estimated mass with the periodic table values. Y. Yttrium molar mass approximately 88.91 AMU/Zr. Zirconium molar mass approximately 91.22 UNB. Niobium molar mass approximately 92.91 AMU/Th. Thorium molar mass approximately 232.04 AMU. Conclude the correct identity. Zirconium, Zr, is the only element in the list with an average atomic mass matching the mass spectral data, approximately 91.2 AMU. Confirming option B is the correct answer. The correct answer is option B, Zr.